Welcome! In this video series, we'll walk through how ApertureDB workflows simplify end-to-end data operations for multimodal AI applications. Today's workflow lets you query ApertureDB as if it were a SQL database. With this workflow, you don't need to learn the ApertureDB query language. You can just query using SQL. Let's begin. I've created a new ApertureDB instance and launched 4 workflows. 2 of them, ingest datasets and website chatbots, are just to populate the database with some information. The SQL Server Workflow is the one that provides the SQL interface. Jupyter Lab will allow us to demonstrate the SQL capabilities. Once the Jupyter Lab workflow is up and running, we'll connect to it and select the SQL notebook. The first thing is that it is going to ask us for the password. We get the password from the connection helper. Now we're clear to connect to the database with a simple test query. The first question we might have is what tables are available to us. There are 4 types of table. System tables represent the ApertureDB system object types like image, blob, bounding box, descriptor, and of course, entity and connection. These will allow us to do object retrieval and operations. Entity tables represent the user-defined entity classes. Here you'll see we have crawl documents, text segments, and many other things. Connection tables represent the various connection classes that we have defined. These are the edges in our graph. Together, the entity and connection tables will allow us to perform graph queries. Finally, we have a descriptor table for every descriptor set in the system. One of these is for the Cocoa images, and another for the text segments from our website. Next, we're going to look at some entities. We can do this in 2 ways. We can look across all entity classes using the system entity table, or we can pick a specific entity class and look at its entity table. We can do the same thing with connections. We can treat it as an unlabeled directed graph using the system connection table, or we can use a specific connection table. In SQL terms, the connections can be considered to be like join tables. Each connection table has columns for the source and destination of the connection edge. Now we can simplify graph queries and track down connected information. Here we're drawing on 2 entity tables and a connection table, and we're describing 2 joins between them, connecting the unique identifiers of the 2 entities using the source and destination columns of the connection. How does that translate into ApertureDB queries? You can use the explain keyword in front of your query to see details of how it is all done. You'll see here 2 calls to find entity and 1 to find connection. But graph queries are only one of ApertureDB's many capabilities. ApertureDB will also act as an object store, returning the raw bytes associated with things like images. Because this is expensive, we don't do it by default, but require the user to turn on this feature using a blobs flag. Another special column is as format, allowing us to specify that we want images to be converted into formats like JPEG and PNG. Here you see that we fetch some images and are able to display them in the Jupyter Notebook. But there's more to ApertureDB's multimodal features. We can also specify operations to be performed on the image, like thresholding, cropping, flipping, rotation, and resizing, all the tricks in the data augmentation toolbox. Here we are using the special operations column and some convenient SQL functions to build an operations pipeline to process the image. Now we see those same images, but manipulated almost beyond recognition. That was a complicated query. What does it look like on the ApertureDB side? As it turns out, it's pretty similar. In this query, you can see the call to the find image command. Among the command parameters, you'll find blobs, as format, and operations, all looking much the same. A third major area of ApertureDB is its ability to store vectors and perform searches against them. This is used for find similar searches, such as those done in the retrieval part of a RAG pipeline. Here we're using the descriptor table generated by our website chatbot workflow, and we're using the special find similar column to look for documents that are similar to our example text. We're using the find similar function and supplying 2 parameters, the text to use as a query and the number of neighbor vectors to return. You'll see that the result documents have similar themes, but might not use exactly the same words to describe them. When we use explain again, we can see parameters like kneighbors as expected, but where is the text? Right at the bottom, you'll see a new thing, the query blob. This reflects the fact that the SQL wrapper has automatically determined the appropriate embedding model to use and has applied it to the text in order to produce an embedding vector, shown here as a binary blob. It is also possible to do the same thing with images. We've reached the end of our Jupyter Notebook, where this workflow demo walked us through the 4 types of table it publishes and how to use them to do graph queries, object retrieval, image manipulation, and vector search. But what if I don't want to write SQL? The good news is that there are many dashboards, BI tools, and other systems out there that have Postgres integrations and will write the SQL for you. With ApertureDB's PostgreSQL query layer, all of these tools now effectively have an ApertureDB integration too. I'm going to demonstrate one of them, Grafana. I select the Data Sources tab on the left, click Add Data Source, and search for the Postgres plugin. I need to fill in the host name, database name, username, and password. These are all provided in the connection helper. Then I click on Save and Test at the bottom, and I have my ApertureDB data source. I have an ApertureDB instance already set up that contains historical information pulled from Docker Hub about how often our images have been downloaded. We enjoy seeing how popular they are, especially the standalone Community Edition that you can easily run on your home computer. I don't have time to explore all of the capabilities of Grafana, so let's just do a simple example. I'm going to create a new visualization, a time series chart. I'll select my PostgreSQL data source. Now I select a table and pick out 3 of the columns: the timestamp, the poll count, and the image name. In the little window below, you'll see that Grafana has generated a SQL query for us. This will be sent to our workflow to get the data to make the chart. Plugins like the one for PostgreSQL allow Grafana to build charts from many different data sources, and now ApertureDB is one of them. Now we can test the query in table mode and preview the results. The table is a nice demonstration that our data is getting through, but what we really wanted was a chart. To make that work well, I've added a couple of transformations. I think that's everything I need, so I'm going to run the query and see what I get. Nice. You can see the standalone image and the related community image have been building up their usage over the last year. That's all we have time for today. I hope this overview of the new SQL Server workflow and its capabilities has been helpful. Now it's your turn. Give it a try and see what you can do. To get started, visit aperturedata.io or scan the QR code for additional resources, including links to our documentation and GitHub repository.